that we're doing functions in class at the moment. Will we be doing Euclidean geometry this term?
It depends on what your school has planned. So if your school is following the ATP as set down by the government, then yes, you will do Euclidean geometry after you've done functions and inverses. What we do at Watobe is we try and follow the ATPs that the Department of Education sets down as closely as possible. The reason that we haven't done functions and inverses at this point is because inverses are a very, very, very small part of the syllabus. So to be honest with you, at the end in trials exams and at the end of the year in your finals, you're probably looking at about 5 to 8 marks on inverses, and it's actually a very big section for not very many marks. So we took the decision to rather focus on geometry, which is a much bigger section. It's 50 marks in your trials exams and in your final papers. So, but yes, we will go back over all of these concepts throughout the year before you write your exams. We do boot camps, we do we've got lessons coming up on Saturdays, I believe, at some stage. So yes, we will get to cover all of that eventually. Okay, hope that answers your question. All right, so here is the homework from last week. I asked you to do, well, this was one of the questions that I had given you. There were 3 questions, so you should have been able to work out that x was equal to 10. Sorry, this is not sitting nicely in the screen here. Okay, so please take a screenshot of this. For those of you that did this one, so I'm just going to write the answer here. So x was equal to 10. There we go. Take a screenshot of that so that you're able to go and mark your work. And then I'm going to hop over and go up here. This was another question, was question number 6 that I asked you guys to do. So here is the answer in red next to it. Okay, so this is 6 over here. Please take a screenshot of that. Okay. All right, so hopefully everybody's got screenshots, which means we can now carry on with the lesson today. Yeah, don't panic. All of these lessons are recorded. They're all available on the website, so you can go and watch the previous lessons. And also don't panic about the order in which we do things, because we have so many students from so many different parts of South Africa, all at different schools covering different topics at different times. It's very difficult for us to plan our courses in such a way that absolutely everybody is doing the same thing all the time, because that's just not going to be possible, obviously. So what we do is we try and follow the government ATPs as closely as possible. So there probably would be a number of you that have started Euclidean geometry, and then there would be some of you that have not done this at all before. But based on the fantastic work we saw last week, I have absolutely no doubt that you're going to be able to do this. And if there are any topics that we haven't got to yet, I promise before you write exams, we would have gone through all of those things. Okay, so let's go back to what our lesson is about today. Today we're talking about the proportionality intercept theorem again, and now we're going to deal with questions that are a little bit more difficult than the ones that we saw last time. So in our first lesson last week, we were looking at the proportionality intercept theorem as it applies to a single triangle on its own. All right, so now that we have figured out how to work in one triangle, we're going to see what happens when we've got 2 or more triangles that have been given to us. All right, so for example, this example that I've got up here on the board. All right, so they tell us that line ED is parallel to line BC. So I'm just going to highlight that. So ED is parallel to BC. So when they tell us that ED is parallel to BC, which triangle are they implying we can work in? Which triangle are they suggesting we can do proportionality intercept theorem in? Which triangle do you think they are asking us to look at by telling us that ED is parallel to BC? Anyone got any idea? You're welcome to unmute or put it into the chat. There we go. That's it. Lovely. Well done. Okay, so they are directing us to triangle ABC. Okay, because it's sides AB and sides AC that are cut into the same proportions. Very nice. Then they give us a further bit of information. Let's do this in green. They tell us that EC is parallel to FD. So EC is parallel to FD. Which triangle are they now directing our attention to? What other triangle? What is the name of the second triangle that they are suggesting we can work in? No problem, Kevin. I'm glad you're with us. What is the second triangle? Let's see. Masejo says AEC. Very nice, Masejo. You caught on to that very quickly. Okay, so it's this triangle over here. So I'm going to rub this out. I'm just pointing this out to you, okay? Because when we are working with proportionality and intercept theorem, and we've got more than one triangle, the first thing that we need to do, our starting point in every single case, is to identify the triangles we can work in. In other words, we want to try and identify the triangles that we can apply our proportionality intercept theorem to. So we have to have one line parallel to the third side of the triangle, and it's going to cut the other two sides into the same proportions. Now we can go and have a look at the information that they have given us. And if anything that they've given us is not on the diagram, we now want to put that onto the diagram. So they've told us that AD over DC is 5:4. So 5:4. And they've also told us that AF is 3x minus 5 units long. And FE is 2x units long. They want us to calculate the length of EB. So what we've got to do here is we've basically got to start with a question, and we need to work our way backwards to our starting point. No, Pinga. Proportionality intercept theorem is a part of Euclidean geometry. Okay, so functions and inverse functions are in paper 1, and Euclidean geometry is in paper 2. Right. So my question to you is, right, if we want to get the answer for EB, they are directing us to the pink triangle. Can you make me a proportion with EB in it that we could use to solve the pink triangle? But this is not where we're starting. This is going to be the second step. All right. So in other words, we're working backwards. What we want is EB over something like AE. So EB over AE would be the same as DC over, what would that be? DC over, can anybody tell me what the denominator would be?
EB.
EB? Did I misunderstand? I don't know who was talking. Who was that, Yolanda? Okay, so a whole lot of you putting it into the chat.
Sorry, that was David.
Oh, okay. Did David say AD?
No, ED.
ED. Okay, all right. So, okay, so you are saying, well, I'm saying, sorry, EB over AE is equal to DC over AD. All right, that is perfect. But now the reason I cannot start here, this is the last thing I'm going to do. It's not going to be the first thing I do. The reason I cannot start here, matrix, is because EB is unknown and AE is unknown. And I only have AE in terms of X. DC I know is equal to 4 and AD is equal to 5. So if I want to solve for EB, it means that I need to know what AE is. So working out AE is actually my starting point. This is where I want to begin. I need to know how long AE is. So I cannot begin working in the pink triangle. I have to begin working in the green triangle. So we're going to come back to what I've written in pink. Let's focus on the green triangle because this is going to be our starting point. So in triangle AEC, I would like someone to tell me what proportion I can make so that I can work out the value of x. What proportion can I make in the green triangle that will help me solve x? Any idea? Anybody want to share an idea? What proportion can I make in the green triangle?
Let's go. I see Spamandla is busy thinking. Let's go. Lihlabi, any idea? Oratile, are you there? I'm going to pick on you guys. So you better talk to us. Let's try anything that comes into your mind. What do you think?
So Sishana has given us a starting point. Sishana, oh, sorry, Shisana. That is excellent. I don't know if the rest of you can see what Shisana has put into the chat, but that is very, very, very nice. So Sishana has written 3x minus 5 over 2x is equal to 5 over 4. I am so impressed. That is absolutely brilliant, Sishana. You have got 100% the right idea. Okay, excellent. Now, what we need to provide here is a reason. Okay, so we mustn't forget our reasons because it is worth a mark. So next to this, what am I going to write? What's my reason going to be? Anybody want to suggest a reason? Do you remember from last time? Proportionality, intercept, theorem. And then what I must do is I must not forget to name the parallel lines. That's it, Ola. Okay, proportionality, intercept, theorem, and I need to name the parallel lines. So in this case, FD parallel to EC. Very nice. Okay, now in order to be able to solve for x, I want to cross multiply. So I need to multiply 4 with 3x minus 5, and I need to multiply 2x with 5. So I've got 4 into 3x minus 5 is the same as 2x times 5. There's my product. Okay, so that's going to give me 12x minus 20. And on this side, I've got 10x. And now I'm going to collect like terms together. Move my 20 to the other side. So if 2x is equal to 20, then it means that x must be equal to 10. Okay, so now I have established what x is equal to. That means I can work out the length of AF and the length of FE. How long is AF? AF is going to be 3x minus 5, so that's 3 times 10 minus 5, so that gives me 25, and FE was 2x, so that's going to be 2 times 10, which gives me 20. Okay. Now that I have worked out, lovely, now that I have worked out what AF and FE are, I can go back to what I was doing in the beginning, right? What I mustn't forget to do here is to name my parallel lines. So I'm going to rub that out because that actually is what would come second. This is what we would do first. And now our second bit would be to go into the pink triangle as we originally agreed. All right, so here we have put EB over AE. And we said that that was equal to AD over DC. We mustn't forget to write our reason, proportionality intercept theorem. we mustn't forget to name our parallel lines. So ED parallel to BC. Now, if I want to work out how long AE is, what am I going to do? AE is AF plus FE. So that means it's going to be 25 plus 20, which means it's going to be equal to 55. So now I can go and sub back in. I've got EB, which I'm looking for, over AE, which is 55, is equal to AD. The proportion of AD to DC is 5 is to 4. Cross multiply. 275, and that means that EB is going to be equal to 275 divided by 4, which gives me an answer of 68,75.
So sorry, Teacher Lee. So I see on the charts, we are correcting the.
Oh, sorry, did I make? Oh, sorry.
So it's 45 and not 55.
Quite right. Sorry about that.
No, they're very good. They're very observant.
That's wonderful. I'm so glad. Absolutely.
Yeah.
Thank you so much. All right. So that was supposed to be 45. Sorry. Thank you. 45. And then let's just correct this over here. Okay. So it was 4EB is equal to 5 times 45, which is 225. And then we've got to divide that by 4 and get 56,25. Okay, there we go. All right, are there any questions? Okay, so you've got EB is equal to 36. Did I do something stupid here? No, Lutundo, did I make a mistake?
Hi, ma'am. Yes, you did. You switched the DC. So the DC is supposed to be on top and then the AD at the bottom.
Oh, how stupid am I? Okay, hang on. Let's go back and have a look at this. So it is EB over AE. Yes, sorry. You're quite right. This was my mistake over here. Sorry, I apologize. Sorry. This was my mistake. Sorry, guys. Okay. Thank you. Okay, well, my reason's not wrong. All right.
Amazing.
Sorry. You're quite right. Okay, so what I did here, beg your pardon, let me just correct this, all right? We are working with side EB, which is this bit, over side AE, which is this bit over here, right? So in other words, it must be DC over AD. So I was supposed to put DC over AD over there. Beg your pardon, proportionality intercept theorem. And again, it's the same lines that are parallel. So it was ED parallel to BC. Yes, there we go. Okay, so now we can go ahead and go and sub in. EB is what we were looking for. We know that AE is equal to 45. DC was 4. AD was 5. There we go. That's a little bit better. So that means that 5 times EB is equal to 4 times 45, which is 180. That's better. So therefore, EB was equal to 36. Yes, 100%. Sorry about that. Well done for noticing. I'm so sorry. Okay. Okay, Tundle, where to? Were you with us last week?
And also, don't worry, we have a recorded last week. You can go watch the previous lesson and take screenshot there or write the notes there. You'll definitely understand all the theorem that we've explained.
All right, that's why Tundle where to. I'm so sorry. Okay, so you're gonna have to go and watch the previous video and then you'll see why we're at where we're at this point. Okay, any other questions? Does this make sense? Are we feeling good? Thumbs up, thumbs down? How do we feel at this point? Cool. Thanks, Ola. Thanks, Shailene. Thanks, Shasana. Oh, thank you. Good stuff. Well done. Okay, you guys are brilliant. Thank you so much for picking up my silly little error that I made and for being so forgiving. I really do appreciate that. Okay, so now let's give you guys something to try. All right, so this is the one that I want you to do. Let's just see if I can make that a little bit smaller, and then it's in the middle of the screen. There we go. Okay, so you guys are going to try this question now. Yes, Tundle, where to go for it? You can ask. Everybody else is just going to carry on with number 12. I'm happy to help you.
Ma'am, can you hear me?
Hello. Yes, I can hear you. How are you?
I'm good, thanks. How are you, ma'am?
I'm fine, thank you.
Yes, yes. I was asking where can I find the videos, the previous activities and the previous
Okay,
things
so
you've done.
that's fine. So Tundle, where to? We are already on the third lesson in this course. All right, so you've missed the previous two lessons. If you log into the website, you will see where our past lessons are. Yolanda, where is it exactly on the website?
You can see if it says watobe.com, you will see you have to choose your grade there. Then you just select your grade. You must scroll a little bit down to see the previous lessons. And then you can just choose your grade, grade 12, and then you will see what we have done so far.
Okay, thank you, ma'am.
So no problem. So Tundle, where to go and watch the lesson on the revision of grade 11 Euclidean geometry, and then go and watch proportionality, intercept, theorem basics. Okay, and then you'll be at the same place where everybody else is. Okay.
Yes, yes, ma'am.
All right. Oh,
Remember,
sorry,
take
Darren.
screenshots. Darren, no worries. We got you. We recorded the whole thing. After 24 hours, you can definitely go and watch it. Okay, on Watobe's website, you just go to your grade and go to today's date, and you can clearly watch it. Will be there for you. Y'all are doing really, really great. Just in any moment, make sure you take screenshot because you never know with network and everything else on your side. So it's best to take a screenshot and then start working on your books, or, you know, try to do the question also.
I'm just going to see if some answers come up for question number 12. And if that is indeed the case, then we can move on.
Not yet, but I see Lorraine is focused. Yes, Lorraine, I can see you, girl. Let's do this. Ali, hope you're working. Katleho, Mbuso. Yeah, I'm gonna pick on you because I haven't seen any answer. So I guess we're still trying to figure it out. Let's do this, my people. We can do it. Let's hope. Let's do this. Inga, maybe it will be best for you also to watch the lessons. And after when teacher Lee explains also the answers, yeah, you can see how she does it, and then you can follow. But if not, you are allowed to rewatch the lessons that we have done. It will really help you a lot and put you at ease, because teacher Lee is a very good teacher. So every single explanation is actually proper, I'm telling you.
Thank you, Linda. Well done, Katleho. Yes, Masejo, I see your answer.
Katleho, which Katleho? I'm told
Please stay on mute. Thank you.
Sorry, I've muted everyone. Teacher Lee, can you please unmute? Sorry about that.
It's fine, no problem. Okay, so there's two different answers that are coming up in the chat. Some people are saying 24, other people are saying 25. I wonder if that's because it said RS correct to the nearest whole number. Okay, so maybe some people rounded up when we were supposed to round down, but that's really not the end of the world. Okay, all right, so the very first person who put an answer up for us was you, Katleho, if I remember. Yes, it was. All right, so Katleho, do you want to explain to us how you got RS is 24? Are you happy to do that?
Yes, ma'am, I don't mind.
Cool,
Hi,
go for
everyone.
it.
So ma'am, I started first by like calculating for SU.
Okay.
So SU over TU equals to WS over QW.
Yes, I agree with you. Keep going.
And then ma'am, I just like, what's that word? Substituted, if that's correct. So ma'am, SU over 6 equals to 11 over 12. Oh, sorry, ma'am. I really did not write the
reason. It's all right. It's a very common thing that the matrics do, is that they carry on working out the question and then they don't write the reason. It's okay. That's why I just keep doing it for you. So don't worry. Okay, so you said SU over 6 is equal to
11 over 12.
keep going.
So ma'am, and then ma'am, I cross multiplied and then I got 5.5.
Good, well done.
Yes, ma'am. So ma'am, TS equals to TU plus SU, which is 6 plus 11, and it is 11.5.
So just say that again. TS is equal to 6 plus 5.5.
Yes, ma'am. Which is 11.5.
Which is quite right. Okay, lovely. All right, keep going.
And then, ma'am, I said RS equals to, so, okay, I'm sorry, I made a mistake. RS
It's okay.
over TS.
RS over
TS equals to QS over WS.
fine. And then what mustn't you forget to put here?
The reason, ma'am, which is
Okay.
called intercept theorem.
Okay, and then QS over WS. So now which are the parallel lines that you've got to name?
WT is parallel RQ. Yes, ma'am.
Perfect. Keep going.
So, ma'am, RS over 11.5 equals to 23 divided by 11.
Very nice. Well done. Very good. Okay, and then you would have cross multiplied and you would have said 11.5 times 23. That would have given you 264.5, and then you divided that by 11 and you ended up with RS is equal to 24, which is correct. Okay, very nice. That is lovely, 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 lovely. Well done. Okay, very nice. This is not the only way that we could do this, right? There is a sort of slightly different way that we could do it, but we would end up with exactly the same answer. Okay, so Katlego, what you've done there is absolutely brilliant. Well done. Anybody do anything a little bit different to you, to Katlego? It would have been sort of in this bottom part, I would imagine. Was there anybody who did anything a little bit different? No? Okay. All right. That's very good. Well done, Kakleho. Excellent work. Okay. Now let's go down and go and have a look at this question over here. Offense, it doesn't matter. Okay, so it really doesn't matter. We can leave it as it is. Okay, you're not going to get penalized for not, if you exclude the units, you're not going to be penalized for that. Okay, all right. Okay, so let's have a look at this question. All right, so let's just make it a little bit bigger. Okay, so here they give us in the figure, EHG is parallel to FC. So in other words, they are telling us, so EHG is parallel to FC. Okay, so that means that they are telling us it's possible for us to work in triangle EBG. Right, because we've got a line parallel to the third side of a triangle. Then they also give us some ratios. So AH over HC is 6 over 5. And AE over EB, AE over EB is 3. AE over EB, EB is this bit over here, that is 7. What they want us to calculate is the value of BG over CG. Okay, so there are no lengths given. They've only given us proportions, and they want us to work out the value of BG over CG. So as I was trying to illustrate to you in the previous question, all right, you need to try and work backwards to find a starting point. So I want this to be a little bit more interactive. Instead of me just telling you guys what it is that you're supposed to be doing, I want you to tell me where you think our starting point is in this question. What do you think the first thing we should try and establish is? So if you think back to the previous example, I had told you, I'd given you a strategy that you could try and use. Let's see if you can figure out what I'm talking about here. Where is our starting point?
Ma'am,
Yes, Katlego.
ma'am, won't you start with like finding the, I don't know what you call it for GC?
What for GC?
Ma'am, I don't know what you call it, but it's like the number for GC.
Okay. There were a couple of people that have put suggestions into the chat, Katlego. So Kutwano has said find EF, and at almost the same time, Letu said find the length of FE. Okay, so Kutwano, you were first. Why did you say find the length of FE? What gave that away to you? What made you focus on FE? Can you explain that to me? So Shailene says to find EF, okay, and then BF. You're on the right track. Very nice. Okay, I'm so impressed with what it is that you guys have said. You are starting with what they've given us and you are working backwards. Your thinking inside your head is, okay, they want the value of BG over CG. So what is BG over CG equal to? So BG is this side over here, the whole side, over the smaller side. So it's this whole side, which is BE, over this smaller side, so BE, over this smaller side, which is FE. They want the value of this. We know what the value of BE is. We know that it's equal to 7. So we don't know what FE is. So that gives us a lovely starting point, because if we can work out FE, we've got the answer to our question. So I am super impressed that you realized that that was what we needed. Okay, so this gives us a place to start. So we establish what BG over CG is equal to. We substitute in whatever they've given us and we figure out what's missing. What do we need? So we need to work out what FE is equal to. All right, so now back to the diagram. How are we going to calculate what FE is equal to? Someone can unmute and tell me what you think we should write. Please, I love hearing what you guys have to say. How are we going to work out FE from what's given? Any ideas?
We can do this, guys. Remember, we don't mind if you get it wrong. We just want someone to try, to give it a try.
Absolutely.
Yes, Gomo. Gomo wants to try. You can unmute Gomo.
So we're trying to find FE, right?
Yes.
Okay, so how I'd do it is that I'd say AH over HC is equal to AE over EF.
Okay, so you're saying AH over HC is equal to AE over EF. Yes, your reason?
I forgot the reason, but yeah.
Proportionality
then,
intercept theorem.
yeah.
Okay, and which lines are parallel?
EHG, but well, in this case it's EH and FC.
Brilliant. Brilliant. Keep going. I love it. I love it. I love it.
So that's gonna be 6 over 5 is equal to 3 over EF, and then you cross multiply, so it's going to be 6 EF is equal to 3 times 5, which is 15. And then EF will be equal to 15 over 6, which is 5 over 2 or 2,5.
Okay, now, what I want you to do is resist the urge to write it as a decimal because we are working with ratios. So when we work with ratios, remember, we haven't got the lengths of any sides here, okay? So we're not allowed to work with decimals when we're working with ratios. We've got to be working with natural numbers. So originally you said to me that this would be equal to 5 over 2. So let's leave it like that. That is fantastic. What are we going to do with it now, Homo? That 5 over 2.
The 5 over 2, man.
Mm-hmm. So you've got FE. Go back to what we were thinking about originally at the top of the page. Remember BG over CG.
Right. I'm going to say 7 over 5 over 2, I think.
There we go. Okay, so we would have to go back and finish this off by saying BG over CG is equal to BE over FE. Okay, and again, we would have to say proportionality intercept theorem and name our parallel lines, which would be FC parallel to EH. Excellent, Homo. So now BG over CG, what did you say I needed to do? 7 over?
7 over 5 over 2.
Excellent. Okay, and now because this is a ratio, I've got to write it as a ratio. I'm not allowed to write it as decimals. Okay, so now we're going to work that out on our calculator. And what are we going to get as an answer? Are you guys getting 14 over 5?
Yes.
Good. Good, lovely. Okay, and you're going to leave it like that. You're not going to press the SD button. Okay, so do not press SD. Okay, because you are not working with a length, you are working with a ratio. Okay, so you are not working with a length.
Ma'am,
Yes, Katleho.
ma'am, I'm kind of lost. Like, ma'am, can you please just re-explain, ma'am? Even if you don't work it out, ma'am, because I do understand some parts, but I don't really like understand the whole thing. So, ma'am, if you
Okay.
just re-explain, ma'am, then I can put it
All right.
together.
Where did I lose you?
The first part, ma'am, I'm still trying to understand the whole thing.
Okay, all right. So are you okay with what everybody said? We're trying to work out what FE is. Because if we get FE, it means we've got our ratio, because we can say 7 divided whatever this value is. So that's why we have to work out what FE is first. So that means that we need to look carefully and find a triangle we can work in. So we see that FE is this part over here. So there is a triangle over here that I'm drawing in green with this line parallel, EH parallel to FC. So that's what we were doing over here. We were working in the green triangle and we were writing AH over HC is equal to AE over EF or FE. We're working in the green triangle. We subbed in the 6, the 5, the 3, and we calculated what EF is. Okay, so EF ends up being this value, which is 5 over 2. Then what I'm doing is I'm taking this value of 5 over 2 and I'm substituting it back in here. Okay, but I've got to set my work out correctly. So when I write BG over CG, I'm back in the purple triangle. So I've got to make my proportion and I've got to write my reason. So BG over CG is BE over FE. They wanted me to solve for BG over CG, so I'm going to substitute in that 7 that I originally had. I'm subbing in the 5 over 2 that I have calculated, and now I'm saying 7 divided by 5 over 2, and that's where I've got the 14 over 5 from. Okay, so this is a ratio. It is not a length, so I'm not going to press the SD button. Okay.
Yes, ma'am.
Okay. So what I'm going to do now is I'm going to give you guys another question. Right? This again is a little bit more difficult. We're working with ratios. We're not working with lengths. Okay, and I want you guys to try this question. So iPhone, I see you were asking, sorry, I'm calling you iPhone. Is there a question you want to ask? Everybody else continue working?
Yeah, iPhone, which I did ask for your name, by the way. I think he was on the line of what Atlejo was asking.
Okay.
You want to go up for screenshots?
Okay, no problem. I'm just going to go up. There you go. Take a screenshot, and then I'll just move it down again. And then I'm going to move it down a little bit. Here you go. You can take another screenshot. No problem, Lutando. Okay, there we go. We're going back down to the question.
Let's go, guys. Teacher Lee is very nice. She's giving us hint by filling out all the pieces that we are given.
Yes. Tony Jabir, you've asked a question. Is there a situation where the line is the midpoint of a triangle? Absolutely. So midpoint theorem that you learned about in grade 10, proportionality intercept theorem is related to midpoint theorem. The only difference is that in midpoint theorem, you've got a midpoint, whereas here, it's not necessarily a midpoint. So yes, they would have to point that out to you. They would do that in one of two ways. So if they gave you a triangle and you had one line drawn parallel to the third side, let's say this is triangle ABC, and let's say that's DE over there. So either they could say to you, D is the midpoint of AB, or the other way that they could say it to you is AD equals DB. Then they've implied that there's a midpoint. Okay, so yes, Tony, very nice question. Thank you. Okay, so iPhone, you've asked a question again. Would it be wrong if we were to say EH? Oh, are you talking about that question up there again? Okay. EH. iPhone, let me just write this down and then I'll go back and have a quick look. EH over.
And sorry for calling you iPhone. It's because
Yeah, sorry for calling you iPhone. Please tell us your name and then we don't have to call you iPhone anymore.
Yeah. We keep on calling you iPhone, and he's like, no, no problem.
Yes, EH over HG would not work in this case. Okay. Because EH over HG, that's not the side that's cut into proportions. Okay, so because FC is parallel to EG, the two sides that are cut into proportions, the same proportions, are BG and BE. So yes, that would be wrong. Okay, you can't do that. No, Tony, it's not part of the sine rule, area rule, and cosine rule, although we can apply the area rule in these questions. In fact, there is a question which I'm going to give you for homework where they've got the area rule in the question. But I will explain that to you next time more thoroughly. I just haven't had a chance to do that yet. Yes, Sunday, you've got a question. Please unmute and ask.
I think we are suffering connectivity there with audio. So it's gonna take a while until she gets her network on.
Okay.
Sorry,
And then iPhone said Kabisa Fingo. If you can change the name, please. Okay, so this question is a little bit more difficult because they're asking us to prove that something is true. All right, so we're not allowed to start out by assuming that it is. I see we've only got about 6 minutes left, guys. So that's why I'm kind of jumping in here now just to sort of give you an answer to this. Has anybody think they've done it and wants to share an answer? Homo, you said you thought you had it. Would you like to share your answer? You're very welcome. Yes, we're going to mark Masejo.
Okay, so I was close. I don't know where I went wrong.
Okay, go for it. Let's see what you wrote.
Okay, so what I wrote was, first what did I do? I said 9 over 2. 9 over 2 being RP over TP.
Okay, so you said, so let me just write this down. So you said RP over TP is equal to?
Is equal to
9 over 2.
RS over VS. Do you see what I did there?
So you said that RP over TP is equal to RX.
Yes.
So now you can't do that. You can't do that. Okay. So what you need to establish here is which triangles you can work in. Always start with what they have given you and try and work backwards to a starting point. So if they're talking about QU is to UT, that's the same as us writing QU over UT. right? That's what they want us to establish. So what is QU over UT equal to? Which triangle are we working in? So I've highlighted the two lines that were parallel. QU is to UT is this side over here. QU is to UT. So that is going to be equal to QS over SV. So QS over SV. Okay. Try and start there. Again, don't forget your reason, proportionality, intercept theorem. And that is because SU is parallel to TV. So again, QU over UT, do we have QS? Yes, we know it's 2. Do we have SV? No, we don't. So that gives us a starting point. We need to start with SV and try and work out what that is equal to. All right, so now, if we want to work out what SV is equal to, again, we need to establish which triangle we can work in. So if I extend this line down here a little bit, I can apply the proportionality intercept theorem to this. And I think that's where you were trying to go. Okay, Cornwall, you were trying to work with that. So if you want to start with SV, we could take SV and we could put it over the whole side here, which would be SR. All right, so SV over SR, and that would be equal to PR over, so let's just check, SV little over big. So that's, sorry, that would be PT. I beg your pardon, I made a mistake there. It would be PT. PT, the little bit over the whole one, PR. And I think that's what you were trying to do, Hom. Okay, so now I'm working in the green triangle. Again, proportionality intercept theorem, name my parallel lines. So this is PS parallel to TV. So now I can work out what SV is equal to. So SV over SR, I know is 3. PT, I know is 2. PR, I know is 9, as you told me, Homer, which is quite right. So this is going to give me SV is equal to 6 over 9. Okay, which I can write as 2 over 3 if I want to. Okay, and now I can come back up here and I can sub this in. So it's 2 over 3. That means 2 divided by 2 over 3, which is 2 times 3 over 2. That cancels. And I'm going to end up with, no, hang on a second. What have I done here? I must get 1 is to 3. SV. I haven't made a mistake, have I, Yolanda?
No, I'm watching.
Okay.
So now I can't see. But yes, we can start, yeah. And then on the other
Okay.
side.
So now that I know what SV is equal to, SV is 2 over 3. I'm just checking that I have done that correctly. So SV over SR is equal to PT over PR. Yes, that's correct. So SV over 3 is equal to 2 over 9. Okay. So that is 6 over 9, isn't it? Because I'm going to cross multiply.
Yeah.
Okay. So that's going to give me 9 SV is equal to 6. Yes, that was correct. So that means that SV is going to be equal to 6 over 9, which is the same as divide by 3, divide by 3. Okay, so I haven't made a mistake there. Okay, now, I originally said that QU over UT was the same as QS over SV. So that's 2 over 3. So now I've got gives me 3 as my answer. What have I done wrong here?
I don't see it because I mean that's 2 over 3. Then a flip is gonna be 3 over 2. Then the 2's cancel. Then we get a 3.
Ma'am. Yeah, ma'am. So remember, it's 2 over 2 over 3. So it's going to be 2 over 1 divided by 2 over 3. And you do the whole thing, then you'll be left with 6 over 2, which is the same as 3 over 1. So you're left with that ratio, which is 3:1, basically.
Sorry, you're quite right. Sorry. I'm just being a dumb blonde this evening. I beg your pardon. Quite right. So 3 is 3 over 1. Duh. Sorry. We haven't made any mistakes. Yes. So 3 over 1. So that means that. So in other words, QU over UT is 3 over 1. So that means that QU is to UT is 3 is to 1. There we go. Okay. Perfect. 100%.
100%. We made it, guys.
We haven't made any mistakes. All right. So there we go. That was that question. I'm sorry that we're out of time now. What I'm going to do is also just give you, I'm going to give you that one if you want to take a screenshot of that, and then you are welcome to try that for homework, question 14.
If you can help me and Teacher Lee to know how
Pleasure, Lutando, any time. Please do answer the poll.
Yes, please. Yeah,
Ma'am.
we're awesome today.
Yes, who's talking?
Katlego is
Ma'am, it's
talking.
me.
Oh, hello, Katlego. Do you want to ask a question?
Yes, ma'am. I want to ask about like the previous question, ma'am, the one that we just passed. I was kind of stuck where you were stuck, ma'am. So can you please explain the final answer, ma'am? How it got to like 3 over 1? Because ma'am, I was stuck where you were.
Yeah, no, that's fine. So then what I did is I worked out what SV was equal to, which was 2 over 3. And then I came and I substituted in here. So in other words, I've got 2 over SV, which was 2 over 3. So that's 2 divided by 2 over 3, which is 3. And then 3 is 3 over 1. Okay, so I didn't make a mistake there. 3 is 3 over 1. Okay, so any whole number can be written as itself over 1. So if I get an answer of 2, it means 2 over 1. Okay, so what I'm trying to prove here is that the ratio of QU is to UT is 3 is to 1, which is correct. Okay, because 3 is 3 over 1. So that's why I wrote this. And then I said, well, therefore, QU is to UT is the same as 3 is to 1. Okay. Pleasure, everybody. See you on
Okay, ma'am. Thank
Thursday.
you.
Okay, no problem. Oh, I'm so glad, Segofatso. It's a pleasure.